The window for today's launch attempt opened at 1300 Eastern, and it lasts for 3 hours. The pad was cleared of all personnel again at T-minus 4 hours, followed by the start of propellant loading. Propellant loading is now nearly complete, and we're going to top off our tanks and condition our propellant shortly. At approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal flight computer takes control of the countdown. Now, while we wait for T0, let's talk about the process that got us here once again. Terran 1 is 85% 3D printed by mass. The items that aren't 3D printed include rubber seals, computer chips, valves, and other similar items. We see 3D printing as an automation technology, and we believe that long-term 3D printing will rapidly democratize space. We've already been able to unlock rapid part count reduction and rapid design iteration, and we're still very much in the early days of what's achievable. Now, we use two classes of printers here, powder bed fusion or PBF, and vertical wire arc additive manufacturing or WAM.
For those of you that are tuning in today for the first time, powder bed fusion, or PBF, is a process that uses a heat source, such as a laser, to sinter or fuse together particles in a layer-by-layer process. Let's show you an example of a PBF printed part. What you might see on the screen right now is a development part. Specifically, this is a development part that we use for our Aeon R engine. It's an example of a turbopump housing. We use PBF to print our 9 Aeon 1 engines and the single Aeon vacuum engine on the second stage for Terran 1. We have been able to increase reliability through lowering our part count with PBF.
And now let's maybe pull up an example of one of our WAM development articles. Our proprietary Stargate printers use WAM for printing the vehicle structure. We developed a proprietary metal alloy that begins in a wire spool and is then fed into a Stargate printer. It's then heated and cooled rapidly to form small beads that, in succession, create the vehicle structure, layer by layer. That includes the Stage 1 and Stage 2 tanks that hold the propellant, their internal ribs, the common domes, and of course, the nose cone. This is essentially what makes up the bulk of the visible part of the vehicle on the pad, except now it's painted white instead of the native silver that you see here. Now, I do want to mention that Terran 1 was again vertically printed using our 3rd generation printer, but our 4th generation printer will move horizontally to increase print sizes for our next and much larger vehicle, Terran R. But of course, first, we have to launch Terran 1.
That is right. We have to launch Terran 1 today. So for those of you that missed Wednesday's broadcast, let's do a refresher about the Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall with a 7.5 foot diameter. Starting from the left-hand side and the bottom of the vehicle, there are 9 Aeon 1 engines. Each of these engines has a thrust capability of about 23,000 pounds at sea level. This gives us a max total liftoff of over 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle. We have thrust vector control actuators, or TVCAs, on the engines to gimbal the engines during flight. We have completed more than 2,000 engine hot fires, and with 10,000 seconds of runtime across the 191 Aeon 1 hot fire tests. The 9 Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the loads from the engine thrust. And above the thrust structure is the stage with the WAM printed tanks that Arwa just shared about. This holds liquid oxygen on the top tank and liquid natural gas on the bottom tank. These tanks are pressurized using an autogenous pressurization system. We tap off a portion of the propellant from the engine, and this is run through heat exchangers that are mounted on the engines. The liquid propellant is converted into a gaseous state, and then this is piped back into the top of the tanks to maintain our required tank pressures. Above stage 1 is the WAM printed interstage, and this holds our stage separation mechanisms. For stage separation, we use a pneumatic pusher system. And above the interstage is stage 2, which has a single Aeon vacuum engine. This engine has a thrust capability of more than 25,000 pounds in vacuum and has the capability of multiple restarts. Stage 2 also has WAM printed tanks just like stage 1. And above stage 2 is the WAM printed nose cone. For future missions, this would be replaced with a fairing and also have a fairing separation system. As we mentioned, there is no customer payload for today since this is our first launch, but we did design Terran 1 with a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to sun synchronous orbit, or SSO, for customer missions. All data from Terran 1 development will be fed into Terran R. But our Terran 1 rocket is only part of the formula. As we get closer to liftoff, Arwa, how about another status update?
Yeah, of course. We are now at T-minus 31 minutes and counting. We're not tracking any current weather violations. As I said earlier, we're still going to keep an eye on those upper level winds, but the range is still green and the vehicle systems are still nominal. So as of now, we're still a go for our scheduled launch time. Now for our new viewers, here's a little more info about the systems you're seeing on the pad. The rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. This is the black vertical truss structure you see there behind the rocket. And then you'll also see 4 large towers surrounding the pad that make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, we have 4 much smaller black posts called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame you see at the bottom right of your screen is the flare stack. No need to worry there, this is intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see here, but there it is. The small slide-looking structure beneath the vehicle is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs the exhaust plumes away from the vehicle. You'll also see what looks to be 3 different levels under the rocket. The largest and lowest level is the pad deck, and directly above it is the launch table. This is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. It transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system, or hold downs, and the quick disconnect, or QD carriages that provide propellant and other commodities to the vehicle while it's on the ground. And once again, a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare for today's second attempt. So thank you all so much for your incredible work.
These teams have also supported our rigorous test campaigns. Let's go ahead and take a look at Terran 1's journey to launch.
Now, as we approach T minus 25 minutes, we're going to stand by for a situational briefing from the launch director, Clay Walker, in Mission Control. Let's go ahead and listen in. If you're just tuning in, we are now awaiting a situational briefing from Clay Walker at around T minus 24 minutes. I'm hearing here that the team is looking into those upper level winds before we proceed with the situational briefing. We should have an update here in just a few minutes.
Announcement on countdown net is the LD. We're holding the clock at T-minus 20 minutes due to upper wind violations. Stand by for new T0 time.
And as you just heard from Clay, the team is going to hold at T-minus 20 minutes. We're going to continue evaluating those upper level winds and get a new T0. Those white clouds that you see coming out of the rocket are due to venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds when it's coming out. For those just joining us, we are at T-minus 20 right now, and we're actually holding the clock due to upper level winds. The team is currently evaluating this, and we'll provide an update as soon as they have it. However, the vehicle is healthy and the range is currently green, so as soon as those upper level winds slow down a little bit, we'll be able to provide another update.
Et ben écoutez, salut à tous, salut Lewis, salut Tomo. Pour l'instant on est en hold, je suis là. Le seul souci c'est que pour l'instant on ne sait pas réellement quand ça va démarrer. Donc là, s'il y a un hold, on peut recompter sur 45 minutes. Ça sent pas bon, on a l'impression de revivre les épopées d'Astra, souvenez-vous quand on était hold sur hold et ça avait connu à plusieurs mauvaises choses. Bon, en tout cas, le direct continue, on va rester, on va attendre. Bonsoir, tout se passe comme prévu. Crew 5, retour cette nuit. Oui, d'ailleurs, rendez-vous à 2h du matin pour l'amérissage de Crew 5. Je serai au rendez-vous. Il n'y aura pas forcément de facecam parce que là, ce soir, j'ai du monde chez moi. Mais par contre, le direct aura lieu, je serai dans le chat. Actuellement, hold pour cause de météo en altitude, beaucoup de vent. Merci pour la musique. Du coup, donc comme je vous disais, rendez-vous ce soir du coup à 2h du matin, en tout cas pour la prise du direct en ce qui concerne Crew 5. Pour l'instant on a un hold et comme nous a dit Lewis, donc on a des problèmes météo. Donc à mon avis, on va pas se leurrer, je pense qu'on va avoir un premier décalage à 40 minutes. On aura également un deuxième, je suppose, hold, parce qu'à mon avis, je pense pas qu'on en aura un premier. Je vais pas vous mentir, je le sens pas pour ce soir. Et là, on peut même voir avec le venting, donc avec les jets d'air, vous voyez, s'évacuer, le vent qu'il y a. Et alors là, le problème de ce que pourrait nous dire Lewis, c'est le vol en altitude. Enfin voilà. Eh bien, écoutez, on va rester on va rester attentif, on va regarder. Et je reviens tout de suite.
For those just tuning in, we did hold the clock at T minus 20 minutes today, but we're expecting a briefing in the next 5 to 10 minutes on what's happening with the upper level winds that were the reason for us holding the clock. We'll continue listening in and hopefully everything sounds good. For those just tuning in, we once again held the clock at T-minus 20 minutes due to weather issues. Unfortunately, upper level winds are currently marginal, so the team is evaluating live data to determine if we can go ahead and keep rolling the clock or if we need to pause for a little bit longer.
And as we wait on that additional data on the upper level winds and as we get an update from the team, let's go ahead and take a moment to get an idea about all the work that the integrated performance team does for Relativity Space.
Hi, I'm Ryan Kraft.
I'm Katie Wallace.
My name is David Brown.
I'm the Director of Integrated Performance at Relativity.
I'm a vehicle simulation engineer.
And I'm a staff vehicle simulation engineer.
One of the key things that we focus on in the department is connecting all the different teams, making sure the structures work with the engines work with the software, and the software works with the electronics hardware. I was lucky enough to work in a few different hardware startups. This is actually number 5 for me. Worked on electric vehicles, race cars, rockets, and manned spacecraft.
A typical day in the life for me at Relativity can vary a lot, but in general, it'll involve running a lot of different trades and analyses, helping with mission planning tasks, and also building up new simulation capability.
I've spent my entire career working on simulation controls. I started off working in the automotive industry on hybrid vehicles and later moved on to motorsports and general consulting for other industries.
When I saw what was going on at Relativity here about 3.5 years ago, I realized this is the coolest place to be on Earth, and I wanted to join the team. Some of the things that we get to learn every day, I don't think you can learn anywhere else, and the team that I get to do it with just makes it even sweeter. Specifically, some of the big challenges are around figuring out what parts of accepted practice in the rocket industry still make sense for us, and where we should change things, or when we should just throw it out and start over with a completely new approach.
I think one of the most exciting challenges is getting to work on Terran R, especially because our team gets to be really involved with the early design, running different trades and analyses and trajectories. And it's challenging because it's never been done before, but it's really exciting to really get to help shape this new vehicle.
My role is usually involved taking small components and subsystems and integrating them into complex system models, which then have great predictive capabilities. What I find most exciting about this is then taking these models and using that capability to help guide design work.
There's a lot of places where an engineer can come in today and still define how Relativity will do rocket engineering for the next 5 to 10 years. When we look for candidates in the integrated performance team, the main thing that we're looking for is hunger to face really hard problems and excitement to learn as you go. We're just looking for people with different views, different experiences, and different ideas to find the right way to do a reusable rocket next time around.
I think someone who would be a great candidate for Relativity would be someone who enjoys working on complex problems and solving difficult challenges. Having any background with simulation or launch vehicle modeling is always helpful, as well as orbital mechanics or general physics background.
One thing I would suggest for candidates coming from more traditional physics backgrounds is to basically demonstrate that you have the experience of taking the analysis that you've performed on a computer and turning that into actionable insight that you can share with the team and use to help guide design decisions.
Right now the team's about 40. We're looking to double that in the next year or so. We've been growing a lot in the last year, but definitely a lot more to come as we get ready for Terran R and all the fun physical challenges there. One of the very unique opportunities here at Relativity is being part of a lot of technical firsts. We printed our first rocket, we're testing it right now. We're about to go through our first launch, then our first customer, and eventually our first re-entry landing of a booster and reuse of it. One thing that people might not know about working in an integrated performance team in a rocket company is that a lot of us didn't have a rocket background when we came in. People come from cars, software development, engineering analysis, planes, missiles. I feel like the opportunity for a really fast pace of learning across a very broad range of technical topics, you can't really find that anywhere else. I think what draws people to Relativity is it's a unique type of physics.
It looks like we are coordinating a new T0 right now that is going to be at 14:35 Eastern. We're awaiting confirmation from Mission Control at the moment, so we're going to continue listening into them for any further updates. All right, and now the T clock is rolling again. We are now 38 minutes away from our new scheduled launch time of 14:35 Eastern. Again, that's 14:35 Eastern, less than 40 minutes away.
Re à tous. Alors, Lewis, oui, je suis au courant pour Rocket Lab. Alors, pour des raisons personnelles, je ne le ferai pas. Par contre, effectivement, je serai bien là à 2h du matin tout à l'heure. Du coup, pour le retour sur Terre de Crew 5. Et puis, bienvenue à tous ceux qui nous ont rejoints sur le direct, comme Nolan. Bonjour, à quelle heure la fusée va-t-elle décoller? Alors, pour l'instant, ça sera minimum dans 35 minutes. Donc, on est plutôt sur un décollage vers 20h35, en sachant qu'il est possible qu'on ait un nouveau hold. Désolé pour le bruit environnant. Il y a un petit peu de monde aujourd'hui dans le studio. Re-aigle. En ce qui me concerne moi, là, j'ai 2-3 petites choses à faire. Vous inquiétez pas, le direct continue. Je vais simplement laisser ma place à Inspiration Créatif, qui viendra de temps en temps. Voilà, qui s'occupe également de la petite, donc elle pourra pas tout le temps être face cam. Mais elle garde un œil et on croise les doigts. Si jamais il y a un décollage, ce sera sûrement avec elle que vous allez le vivre. Voilà, bah écoutez, installez-vous. Et puis rendez-vous également voilà, à 2h du matin pour l'amérissage de Crew 5. Et de rien, Nolan. De rien, de rien. Puis bah écoutez, désolé pour ceux qui attendent depuis un petit moment. Voilà, ça arrive. Je vous rappelle que nous sommes en présence de la première fusée entièrement imprimée en 3D, en alliage d'aluminium. Même le moteur, alors pour ceux qui la découvrent aujourd'hui, même le moteur est imprimé en 3D. C'est une première mondiale, donc on prend toutes les précautions. Comme l'a dit Lewis un peu plus haut, on a des problèmes météo aujourd'hui, donc bon bah voilà, vous pouvez bien comprendre que on essaye de prendre le maximum de précautions. On va croiser les doigts, ça se trouve dans 34 minutes maintenant ça décollera. Sinon je suppose que ça sera reporté à demain. Voilà. Écoutez, pour ma part, je vais vous laisser là. Je vais peut-être revenir tout à l'heure, mais dans tous les cas, ça sera Inspiration Créative qui prendra le relais. Donc si vous avez des messages, ne vous inquiétez pas. Hop là, j'ai failli faire des bêtises. Tiffany est là pour vous répondre. Sur ce, bah écoutez, à tout de suite, à bientôt.
We're now at T minus 31 minutes, and you might be wondering where we built the launch vehicle that you're seeing on the pad. We currently have 2 manufacturing facilities in Long Beach, California, and today's rocket was printed at our second factory called the Portal, while our new headquarters, named the Wormhole, is home to our 4th generation Stargate printers. This is the million-square-foot facility we are currently expanding into that will serve as the epicenter for Terran development and production.
Speaking of Terran, Terran 1 is truly a pathfinder to that vehicle. The real opportunity in the market, as proven by our customer contracts. We are actually already ramping up production for this medium to heavy lift reusable vehicle. We have designed it to be capable of 20,000 kilograms to low Earth orbit or LEO, and we plan to still benefit from the large-scale metal additive manufacturing. One key learning from Terran 1 is with the engines. Let's take a look at this clip of the Aeon thrust chamber assembly test. So what you just saw there was a full power test of the Aeon thrust chamber assembly. I want to give a special shout out to Jake Shearman, Senior Manager of Combustion Devices, the Propulsion Test Team, and the Stennis test teams for accomplishing that critical milestone. So full power means 258,000 pounds of thrust at sea level. That is what we are designing Aeon engine to. And that is 10 times the capability of the Aeon 1 engine that we have on Terran 1 today. We are already well underway testing components such as a full-scale gas generator test, igniter testing, and as you just saw, that full-scale thrust chamber assembly. We are currently building our integrated engines, and on our Twitter feed, you can actually see an image of our first integrated engine next to a human for perspective on size. We are also completing building of our turbopump assembly, and we're planning to go into full engine tests throughout 2023.
And we're going to test those engines over at the NASA Stennis Space Center in Mississippi, where most of our testing is done. In 2018, we secured the first Commercial Space Launch Act, or CSLA, agreement with NASA Stennis. And we now occupy several operational facilities there, including 4 exclusive use test stands for Terran 1 stage and Aeon engine testing, 2 stands used for Aeon 1 engine tests and Aeon R component tests, and 1 cell for Aeon R engine tests. On top of that, we're building out an additional 150 acres for the Terran program, and we've already started construction on the new engine test stands. Other structures there will include a full-scale second engine stand, office buildings, and of course an integration hangar. All the structures we're completing out there are built from the ground up on previously unused land. After testing, we ship the components to the launch site. We, of course, have our operational site here at the Cape, but we've also acquired a site in Vandenberg, California, as an additional option for future launches. In 2019, we secured a direct agreement from the U.S. Space Force for Launch Complex 16. And Relativity joins just a few others here as only the 4th company with a currently operational orbital launch site at Cape Canaveral. Both Terran 1 and Terran R will launch from Launch Complex 16. With that, we are now approximately 27 minutes away from launch.
This is so exciting. I hope we continue to move forward. But just as a reminder, we do not have a customer payload on board, but we do have a memento in the nose cone. We have included our first ever 3D printed piece from our Stargate printer. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you see there is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with a GLHF for good luck, have fun, and our mitosis logo to commemorate this maiden launch.
And from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. Like the first print, Terran 1 is the first step of many towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle. Now we're currently at T-minus 25 minutes. We're going to continue standing by for further updates from Mission Control.
All parties on net. Situational briefing for pre-go, no-go. All parties be aware the go, no-go poll will be performed in approximately 10 minutes. Primary test objective is a transition into countdown through terminal startup and release into flight. Vehicle status, propellant is loaded. We are tracking no additional items for constraints. And while we are still waiting on one final balloon, we are still a go unless that balloon comes back as negative. All assets are standing by for launch. And we will do polls in approximately 6 minutes. Stand by all parties.
And you just heard that situational briefing from Clay Walker. The vehicle is very healthy right now, and the only issue that we're tracking is unfortunately the weather. But we are awaiting data, the latest data from our weather balloon to determine if we can continue and go ahead with our scheduled launch time of 14:35 Eastern.
As we continue to wait, maybe let's do a recap on the Terran 1 architecture and go ahead and look at this graphic of our Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall and 7.5 feet in diameter, We have 2 stages that are expendable. On the bottom, we have 9 Aeon 1 engines. Each has a thrust capability of about 23,000 pounds at sea level, giving us a max total liftoff of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and as you previously heard, we have thrust vector control actuators, or TVCAs, on the engines that allow us to gimbal during flight. We have completed more than 2,000 engine hot fires as we prepared going into launch today. The Aeon 1 engines are attached to the vehicle through a thrust structure, and above the thrust structure we have WAM printed tanks. Arwa previously shared that this is the wire arc additive manufacturing in-house process that we use. And these tanks hold liquid oxygen on top and liquid natural gas on the bottom. During flight, we pressurize our tanks using an autogenous pressurization system. This means that we tap some propellant from the engines, and this is run through heat exchangers mounted on those engines and converts the liquid propellant into a gaseous state, and we pipe it back to the top to maintain the required tank pressure or ullage pressure. Above the stage 1 tanks, we have a WAM printed interstage, which holds our stage separation mechanisms. This is what we use to separate stage 2 from stage 1 during flight. The stage separation system uses pneumatic pushers. And above the interstage is stage 2, which has a single Aeon vacuum engine. This engine has a thrust capability of more than 25,000 pounds in vacuum and has the capability of multiple restarts. Stage 2 is also WAM printed just like stage 1. And above stage 2 is our WAM printed nose cone, which we just shared about the memento inside of that nose cone. For future missions, we will replace this nose cone with a fairing and also include a fairing separation system. Terran 1 was designed with a payload capacity of 1,250 kilograms to LEO or 900 kilograms to Sun Synchronous Orbit or SSO. All the data from today's launch and Terran 1 development will be fed into Terran R. But note that
to NRC RCS checkouts complete.
We're going to go ahead and pause and listen in on mission control for any more updates. Thank you.
As of now, it seems like everything is on track, and we're going to perform the go, no-go polls in just a few minutes here, so we're going to stand by to listen into mission control.
Copy. All parties on all nets, this is the go, no go for launch. Please provide concurrence to proceed into launch with launch countdown go, no go. BC.
BC go.
BC go. GC1.
GC go.
GC go. GC2.
GC2 go.
GC2 go. Ground.
Ground go.
Ground go. AVI.
AVI go.
AVI go. FTS.
FTS go.
FTS go. RF.
RF go.
RF is go. GNC.
GNC go.
GNC go. Flight software.
Flight software go.
Flight software's go. Prop 1.
Prop 1 go.
Prop 1's go. Prop 2.
Prop 2 go.
Prop 2 go. Fluids 1.
Fluids 1 go.
Fluids 1's go. Fluids 2. Fluids 2 go. Loads.
Loads go.
Loads is go. Rock.
Ranges go.
Ranges go. OSM.
OSM is go.
OSM is go. RC.
RC go.
RC go. Vehicle.
Vehicle is go.
Vehicles go. CE.
CE's go.
C's go. LC.
LC is go.
LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or a manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify the LD and the RC on the primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Now let's take a moment to introduce you to our Mission Control team. As you just heard, Clay Walker, Launch Director, John Wiswall, Launch Conductor, James Harris, Chief Engineer, Elijah Escobedo and Zoe Dickert on Vehicle Controls, Brian Batters, Ground Control, Bill Stack, Ground, Joy Mosdell, Range Control. We also have a few notable members of leadership supporting today's launch, and they are also here at Launch Control with us. This includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Zvatek. These are among many, many others who are making today's launch happen. Let's go ahead and take a moment to wait as we get more updates from Mission Control.
For those curious, you'll be able to see small white pieces falling off the rocket. Not to worry, that is just ice falling off from the frost on the vehicle due to the chilled propellant inside. On the other view, you might have also seen a small flame to the far left of the view, and that is just the flare stack that's used to burn off any flammable gases from propellant loading and venting operations. Once again, those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds. In just about 46 seconds here, we will begin our countdown sequence.
T-minus 10 minutes, countdown sequence has started.
And we're currently at T-minus 9 minutes and 45 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, as you just heard, and we're currently proceeding with our scheduled launch time. In just about 30 seconds, we'll be transitioning stage 1 to helium. And I'm receiving an update here. We just got the data from our latest weather balloon, and we are a go with upper level winds. The weather isn't stopping us today.
Stage 1 pneumatics have transitioned to helium.
And that means we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight,
For engine chill.
we'll pressurize the tanks with autogenous pressurization. That last call out was that we're pressurizing the tanks for engine chill.
We're now getting into the business end of today's countdown. Let's take a moment to walk through the launch timeline.
At T-minus 3 minutes, the transporter erector, or that black truss structure, will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. Then at T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. And we then go into final flight termination checks
to igniters and flight targets.
and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed Aeon 1 engines, so you'll see the flames beneath the rocket at that point. And at T0, we will have liftoff. Shortly after that, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program, and at T plus 80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff, or MECO. This is when the stage 1 engines will shut off. This will be followed shortly by stage separation and ignition of the Aeon vacuum engine. Second stage will burn for a little under 5 minutes, and then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for today's first launch. We'll go ahead and continue listening in on mission control.
We're currently priming the igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across the glow plug.
Stage 1 igniters priming in.
Stage 2 ignited at final press.
As a reminder, GLHF is our maiden launch, so while a nominal flight would have Terran 1 reach orbit today, our primary goal is to learn as much as we can and demonstrate the product concept. A major milestone would be to have Terran 1 make it through max Q, the point of maximum dynamic pressure.
Stage 2 is on internal power.
And you'll now see those cradle arms are slowly starting to release stage 2 at the top there so that the strong back can retract.
Stage 1 TVC checkouts.
Over the next minute and a half, we'll be performing the final thrust vector control health checks on both stages before liftoff. You'll be able to see the engines gimbaling or tilting if we're in that engine view. There we go.
Stage 1 is on internal power. Strong back retracting.
And now that black truss structure behind the vehicle will retract just a few degrees to prepare for umbilical separation.
Stage 2 TVC checkouts.
As we approach T-minus 2 minutes, what you're looking at on your screen is a vehicle that is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final grain status.
Hold, as the MIFCO will hold due to a fouled range.
You heard that call out. Someone is calling a hold due to the range. We're going to stand by for updates. There appears that there may be a vessel within our clear radius. We're going to stand by to hear confirmation from the range. And I just got confirmation there is a boat in the range. We're going to stand by to see if they can clear the boat from our radius. Once again, just to clarify, our vehicle is healthy and all systems appear to be performing nominal. We just got to go for the weather for upper level winds, but unfortunately there is currently a boat in the range, so we're just awaiting confirmation to see if they can clear that boat in time and get it out of our radius.
Announcement on countdown net is the LD. We got a hold called prior to terminal count. Hold gating items have been cleared. We are adjusting for a new T0 time. We'll hold the clock for terminal count until we pick up the count.
All right, now we are just confirming a new launch time. All items that were blocking us and giving us a red range have now been cleared out. So we're going to await that updated launch time and then update the T clock above as necessary. All right, and the clock is about to resume just shortly here. They are coordinating that new T0. We're very excited to get this thing
Countdown,
going.
countdown net. T-clock should pick up in 60 seconds.
60 seconds. We have confirmed our new T0 is going to be 14:42 Eastern. Once again, that's 14:42. We'll see the T clock rolling in just a moment here.
T-clock's rolling. Terminal count.
Pelton Dalton, close out.
Flight computer and countdown.
T-minus 60. GCU with the count. LD, are you go for launch? LD is go for launch.
And we just got that final go for launch from our launch director. We are now just about...
Range green.
Range is green. We're now about 30 seconds away from the moment that we've all worked so hard for our first launch.
Salut tout le
We've had
monde,
a
et bien
lot of
cette
fun with
fois-ci
you,
ça a
Terran
l'air
One.
d'être
Good luck.
bon.
And here we go.
On est à T-moins 15 secondes. J'espère que vous m'entendez bien. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, décollage. Eh ben non, pas de décollage. Mais le compteur est bien arrivé à 0, mais on a encore un hold. C'est pas bon signe. Eh ben, je pense que c'est un loupé. On va voir ce qu'on a comme info. Alors. Je suis d'accord avec tous vos emojis dans le chat. Là, c'est... Ouais. Eh ben, début difficile pour Terran One. Hein. Bon. Écoutez, on va attendre un petit instant, voir si on a des infos, voir ce que ça donne. Eh bébé.
All right, I'm hearing from Mission Control that we're currently assessing vehicle health to confirm if we can do a recycle today and try this thing one more time.
Eh ben, écoutez, merci tout le monde pour vos petits messages dans le chat. Et ben oui, ça va très bien. C'est que je vous ai un petit peu abandonné depuis l'arrivée de bébé, même un petit peu avant. Mais écoutez, tout va bien. Merci d'ailleurs à tous pour vos petits messages, tous les petits messages que vous nous avez envoyés depuis son arrivée. Ça fait très plaisir. Et oui, je suis d'accord avec toi. Ils nous font des feintes là. Eh ben, écoutez, on va voir s'il retente quelque chose. Eh ben, écoutez, Marco est de retour. Il va pas tarder à nous rejoindre.
Eh ben écoutez, à tous. Donc oui, j'ai bien vu, comme vous tout à l'heure, on a eu une interruption du décollage. Bah, moi j'étais sur mon téléphone, j'ai vu, on va dire, tout ça décoller, enfin tout ça s'allumer, mais voilà.
On y a cru.
Bon, je vais pas vous mentir, ça sent pas bon pour ce soir, clairement. Merci encore à tous. Oui, c'est vrai qu'on n'a pas pris le temps de répondre à peu près à tout le monde, mais voilà. Je reviens dans quelques secondes, mais merci à tous d'être là. À tout de suite.
Announcement on countdown.net. This is the LD. We aborted terminal count on a launch commit criteria violation at T-minus 0.5 seconds prior to liftoff. Safing the vehicle and assessing recycle opportunities.
Là, je crois il y a 2 semaines, oui, effectivement. C'est pas très glorieux en ce moment. Comme c'est que la météo, c'est compliqué entre la météo, les problèmes techniques, les... Ouais.
The team is continuing to assess vehicle health to confirm if we can have a recycle today.
Décidément, il y a des allers-retours aujourd'hui. Donc, alors, eh ben, écoutez, ouais, je vais pas vous mentir, je pense que ça sent pas très bon pour aujourd'hui. Je réponds encore à des questions qu'on m'a posées tout à l'heure. Non, je ne ferai pas la diffusion de Rocket Lab tout à l'heure pour des... Bon, voilà, il y a un peu de monde aujourd'hui. Par contre, je serai... En tout cas, peut-être toi, je ne sais pas.
Peut-être.
Tout à l'heure, à 2h du matin, voilà, pour le retour de Crew 5, donc pour l'amérissage. Bon, là, après, on va pas se mentir, on va attendre encore 5-10 minutes, mais si ça n'a pas repris, je pense que de toute façon, on reprogrammera tout ça. La fenêtre de tir était jusqu'à 22h. La coupée, alors, pour le coup, j'ai regardé, je ne sais pas si... Ça m'étonnerait quand même qu'ils ont interrompu le lancement à T-0.
Oui,
T- encore,
oui,
bon.
non, mais là, ils étaient à pile 0, quoi.
Je pense pas qu'on aura quelque chose ce soir. J'ai l'impression de revivre l'épopée d'Astra qui nous avait conduit à des échecs cuisants.
Jusqu'à un gros échec en plein vol, n'est-ce pas?
Voilà. En tout cas, merci à tous d'être présents. C'est vraiment sympa à tous. Je vois qu'on n'avait pas affiché le chat. Il n'a pas dû marcher, mais attendez, c'est pas grave. Quand même. Vous allez réapparaître. Voilà. Allez, c'est mieux que rien. On vous voit tous. Du coup, merci Nolan, merci Aigle, merci Tortue, merci Lewis, merci tout le monde. On va rester encore quelques minutes ensemble. Et puis, écoutez, je pense qu'on se donnera rendez-vous demain ou après-demain, on verra. En tout cas, on se donnera rendez-vous tout à l'heure à 2h du matin. Je serai là à 2h. Moi, ce que je vous propose, vous savez quoi? Parce que là, de toute façon, voilà, on va faire ça. Je suppose pour éviter de vous faire attendre trop. Ce que je vous propose, c'est que de toute façon, s'ils repartent, ils vont repartir au moins à T-40. On va couper le direct là. Je vais pas vous mentir, personnellement, je n'y crois pas. Attends, on va peut-être avoir des infos maintenant. Et si jamais ça doit repartir dans la soirée, on relancera un direct. On va attendre de voir la suite des présentatrices, mais je pense qu'on va faire ça. Mais personnellement, j'y crois pas. J'y crois pas et on va pas patienter pour rien au final.
Non, et puis pour que ça coupe à pile 0, non.
Hop. Bon. Je vais attendre 1 minute pour voir si le compteur se remet. Mais je pense qu'après, oui, on coupera parce que bon, de toute façon... De toute façon, ça va pas repartir à 0 pile. Donc on aura une fenêtre, je pense, quand même assez large, minimum de 20 minutes. Alors là, le problème se pose. Personnellement, je pense plutôt que c'est un problème à l'allumage. Je vois pas qu'on interrompt le lancement à T0.
Non, c'est juste que c'est pas parti et puis que voilà.
Je pense qu'il y a un problème quelque part et je suppose, je ne sais pas la nature du problème, mais si c'est un problème niveau du moteur, je vous rappelle que le moteur est également imprimé en 3D. Donc
3D,
c'est une première à peu près pour tout.
Ouais.
Donc l'ordinateur de bord annulé à moins 5 secondes. Ouais, on a un T-0.
Ouais.
On va pas se mentir, ça sent pas bon pour aujourd'hui.
Ouais.
Tiffany, au fait, du coup, qu'est-ce que ça fait de refaire un petit direct?
Ça faisait longtemps, c'est cool.
Puis c'est pas pour n'importe quel projet en plus.
C'est vrai que ça me va bien, une fusée en impression 3D. Mais ouais,
Ça serait bien que tu nous la crées en 3D, ça serait sympa.
Bon, après, elle est pas très complexe, on va pas se mentir.
Oh, ça fait juste un an que j'attends une Soyuz entre nous.
Justement, la Soyuz est trop complexe.
Ah, ça sonne. Non, attends. Je vais y aller.
As you can see, the T clock rolled back. We are still working on a recycle, so we'll keep you updated as soon as we have confirmation.
Allez, on est de retour. Eh ben écoutez, on est à T-45 minutes.
Ok.
Bon. On est à combien de temps? Écoutez, moi ce que je vous propose, c'est que vu qu'on a de nouveau un compteur, ce qu'on va faire, Tiffany, ça va être très simple. C'est que on va pas attendre 45 minutes comme ça.
Non.
On va couper les caméras, on va laisser le direct. Et puis bah écoutez, on se retrouve tous, au moins à T-5, et voilà. S'il n'y a pas de nouveau... Mais ça sera la dernière, parce que la fenêtre de tir est à 22.
À 22, donc après c'est cuit.
Bah écoutez, on vous dit à tout à l'heure, et puis voilà. Tiff.
Et ben à tout à l'heure.
À tout à l'heure, et bah écoutez, portez-vous bien. On coupe pas le direct, c'est juste l'intro, vous inquiétez pas.
Nous sommes go pour la mise à feu. H-.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6. Départ séquence mise à feu. 2, 1, mise à feu.
Less than 5 minutes away.
Stage 1 igniters priming in.
GLHF again is our maiden launch. So a nominal flight would have Terran 1 reach orbit today, but our main goal is to learn as much as we can about this vehicle and demonstrate the product concept. A major milestone would be for us to reach max Q today, the point of maximum dynamic pressure.
Stage 2 is on internal power.
And the
TE cradle disengaged.
TE cradle, there we go, disengaged. You'll see that cradle arm slowly start releasing stage 2 so that the starting back can retract.
Allez, on est reparti, on est à 3 minutes avant le décollage pour la deuxième tentative de la soirée. Puis rebonjour à Steven et rebonjour Lewis et à tous ceux qui sont encore présents. Voilà, ça va faire bientôt plus de 3 heures qu'on a malheureusement lancé le direct après un premier hold qui s'est arrêté à T plus 5 secondes si on en croit Lewis, puisque les arrêts moteurs automatiques se sont déclenchés peu après la phase finale de déclenchement. Bah écoutez, 3 minutes avant décollage. On va voir ce que ça donne et on espère beaucoup de cette fusée. Et pour répondre à tes questions Steven, puisque tout à l'heure je t'ai répondu dans le chat, vous le voyez de toute façon il est au-dessus de moi, cette fusée est imprimée, et je l'ai marqué de toute façon, cette fusée est imprimée à 85% en 3D, en alliage d'aluminium, comme les moteurs. Les moteurs, eux, c'est 100% 3D. Il y a 9 moteurs, si je ne me trompe pas. De toute façon, c'est toutes les informations que nous ont donné la société de Relativity Space sont marquées juste au-dessus. Mais bien sûr, on peut toujours faire un sujet approfondi. Ce sera peut-être notamment le sujet d'une prochaine vidéo. Allez. Nolan, merci à tous. Il y a Lewis et j'avais vu bon, alors là Tiffany n'est pas là pour le confirmer, mais tout à l'heure je lui ai dit, je sais pas pourquoi je le sens pas Rocket Lab ce soir, de toute façon j'avais décidé de pas le faire, et Lewis nous précise, Rocket Lab a des gros soucis météorologiques pour ce soir, beaucoup trop de vent, actuellement pas d'autorisation de décollage. Bon, comme quoi on est habitué également, et je m'étais pas trompé sur le coup. Allez, on est à 1 minute 33, comme d'habitude je mettrai le son à fond. En ce qui concerne la mise à feu, on se retrouvera peu de temps après. Alors, petite précision par rapport à d'habitude, vu que la fusée est en impression 3D, bon, c'est pas ça qui va changer grand chose, mais il n'y a pas de charge utile. Et normalement, il n'y a pas de système d'éjection de la coiffe. Je peux me tromper à ce niveau-là, mais en tout cas, ce qui est sûr, c'est qu'il n'y a pas de charge utile. Donc là, c'est vraiment un test, savoir est-ce qu'on peut atteindre l'orbite. C'est vraiment le test principal, et voilà. Donc je suppose qu'on n'aura pas de caméra embarquée, ou alors très peu. On va suivre ça, on croise les doigts, on veut la voir décoller. Alors Tiffany n'est pas actuellement à l'écran, mais en tout cas elle regarde, et tout comme moi, elle espère que ça décolle. On voit qu'il y a quand même beaucoup de vent actuellement quand même. Bah écoutez, sinon, bon décollage à tous, merci vraiment à tous ceux qui sont présents depuis le début, n'hésitez pas à partager le direct. Et puis bah écoutez, on a le compteur qui vient de s'arrêter à 45 secondes. Mais pas de hold signalé, on peut croiser les doigts pour un problème peut-être de compteur, ce que je ne crois pas du tout. Oui, c'est confirmé, nouveau hold à 45 secondes. Ça nous rappelle quand même beaucoup les mésaventures de Astra Space. Bon, bah écoutez, on va patienter jusqu'à attendre d'en savoir plus. Et oui, j'ai pas eu ton message à temps, qui était go, lancement, ordinateur de bord, go, espérons. Aïe, témoin 45. Il est 22h. Si je me rappelle bien, la fenêtre de tir s'arrête pile poil à 22h. Ils viennent de retirer le hold. Donc je supposerais que on se donne rendez-vous potentiellement demain ou après-demain. Et oui, c'est ce que vont sûrement nous dire les présentatrices dans quelques instants. On y a cru, encore et encore, mais malheureusement, je pense qu'on va se donner rendez-vous une prochaine fois. En tout cas, n'oubliez pas qu'à 2h du matin, on lance un prochain direct pour l'amérissage de SpaceX. Donc Crew 5 qui revient sur Terre, donc ce sera à partir de 2h du matin. Alors est-ce que je serai en face cam, ça c'est pas encore confirmé, mais en tout cas le direct aura bien lieu. Et oui, là on les voit, on nous souhaite bonne soirée. Et ben écoutez, malheureusement c'est sur ça que l'on va malheureusement terminer le direct. Je suis vraiment désolé à tous ceux qui ont pris du temps dans leur soirée pour assister à ce lancement comme historique, puisque je vous rappelais que c'était la première fusée impression 3D qui allait décoller. Restez actifs sur la chaîne, dès que j'ai une nouvelle date, je vous la mets en diffusion programmée. Et puis voilà, et ben écoutez, sur ce, bonne soirée à tous, et puis bonne fin de week-end. Voilà. Bonne soirée. Salut et encore merci à tout le monde.
Nous sommes go pour la mise à feu. H-.
15,